Now in the question 2, there are 2 green marbles and 3 yellow marbles in a bag. The marbles are identical except of their color. A marble is drawn at random from the bag. In the part 1, list the sample space in the set notation. So first we will have to find out the sample space in the set notation. Since we have 2 green marbles and 3 yellow marbles. So we will write down the sample space in the set notation, just like we will denote the 3 green balls with G1, G2, and G3. And we will denote 2 green marbles with G1 and G2, and the 3 yellow marbles with Y1, Y2, and Y3 respectively. So this is the sample space in set notation. Now in part 2, by using set notation for the respective events, find the probability that the marble drawn is yellow in part A. So, for this, let E be the event that the marble drawn is yellow. So then, E is a subset of S. So then, E will be equals to Y1, Y2, and Y3. And the probability of E will be found out by the number of is equals to the number of elements in the event divided by number of elements in the sample space. So probability of any event can be found out by using the formula. Probability of event is equals to total number of elements in an event divided by total number of elements in the sample space. So the number of elements in the event will be 3, and the number of elements in the sample space, as we can see, are 5. So the probability of an event E will be 3/5. Now, in part B, find the probability that the marble drawn is not yellow. So we have to find out E complement. E complement is the event that the marble drawn is not yellow. So for this, we have P of E complement equals to 1 minus P of E, as we have learned. So P of E was 3/5. And here we have P of E prime, P of E complement equals to 5 minus 3/5, and this will gives us 2/5. So ability that the marble drawn is in part A black and in part B green or yellow. So for part A, the probability of black will be equals to 0. Why is the probability of black equals to 0? Just because this is an impossible event and there is no information given regarding the black marble in the question. Now for part B, what is the probability that the marble drawn is green or yellow? So it will be equals to 1. Why the probability of green or yellow equals to 1? Just because this is a possible event and there is a information regarding the green marbles and yellow marbles in the statement of the question. Now in the question 3, Each letter of the word probability is written on identical cards. One card is chosen at random. In the first part, list the sample space in set notation. So let S be the sample space and S will be equals to. Since the word probability has some repetition of alphabets. So there are two B's in the word probability, and there are two I's in the word probability. So the sample space will be like P, comma R, comma O, comma B1, comma A, comma B2, comma I1, comma L, comma I2, comma T, and comma Y. We will give the different representations to the outcomes B1 and B2 and I1 and I2 just because of repetition of the alphabets. So the sample space in set notation is equals to P, comma R, comma O, comma B1, comma A, comma B2, comma I1, comma L, comma I2, comma T, comma Y. Now in the part 2, what is the probability that the letter on the chosen card is in the part A is B? So the probability if a word or a letter on the chosen card is a B. So it will be here in the sample space, we can see there are only two B's. There are only two letters that are B. So here we have the number of event is 2. And what are the total number of elements in the sample space? So let's count. They are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we will write down in the denominator 11. Now for part B. If the letter chosen is T, then the probability will be 1 over 11, just because we have only one T in the word probability. Now for part C, if the letter is an I or an O, so it will be equals to 3 over 11. Just because we have two I's in the sample space and there is only one O, so if we count, we have 3 elements in the sample space for this event. So the probability for an I or an O will be 3 over 11. Now in the part 4, we have to find out if the letter is an E. So the probability of this event will be equals to 0 because this is an impossible event and we can see that there is no E in the word probability. Now in the part 3, by using the set notation for the respective events, find the probability that the letter chosen is in part A, a vowel. So let E be the event that the letter chosen is a vowel. Since E is a subset of S, so E will be equals to OA, I1 and I2. OA, I1 and I2. And the probability of the event will be find out by using the formula P of E is equals to number of elements in the event divided by total number of elements in the sample space. So in our considered event, the number of elements are 1, 2, 3, and 4, and the number in the elements of sample space was 11. So the probability of E is 4 over 11. So for part B, E prime is let E prime is the event that the letter chosen is a consonant. So since we know that probability of the complement of an event equals to 1 minus probability of an event, since the value of probability of E was 4 over 11, so we will just put the value here and we have 1 over 1 minus 4 over 11 and it will gives us P of E complement equals to 11 minus 4 over 11. And that will gives us probability of the complement of an event equals to 7 over 11. 4. All 8 pangolin species are protected under law under international laws. In Singapore, the method of capture recapture is used to monitor the pangolin population in the nature reserve. In a particular year, 22 injured pangolins were rescued and tagged. The pangolins were then released back into the nature reserve after they recovered. Over the period of 1 year, 5 pangolins were captured on camera, of which only one was tagged. Estimated the number of pangolins that lived in the nature reserve and state the assumptions you have made to solve this problem. So first, we will estimate the number of pangolins living in the nature reserve. So it will be equals to, since we have 22 injured pangolins that were rescued and tagged. So 22 times over the period of 1 year, 5 pangolins were captured on camera. So 22 times 5 gives us 110. So the estimated number of pangolins living in the nature reserve will be equals to 110. Now the assumptions we have to made are 1. No pangolins were born and died over the 1 year. And in the second assumption, the likelihood of a tagged pangolin appearing on camera is same as the likelihood of a non-tagged pangolin appearing on camera. Now in question 5, a survey is conducted to find out which of the 4 activities, saucer, basketball, chess, and reading, students in a class prefer. The pie chart shows the results of the survey. A student is selected at random. Find the probability that the student prefers in the part 1 is saucer. So let S be the event that the student prefers saucer. So P of S will be equals to area of red sector divided by area of circle. And that will be equals to angle of red sector divided by angle of circle. So probability that the student prefers saucer will be equals to Since the angle of a rect sector is given in the pie chart, and that is 135 degrees, and it will be divisible by the 360 degrees, just because we know that the angle of circle is equals to 360 degrees. So after simplification, we will get 3 over 8. So the probability that the student prefers saucer will be equals to 3 over 8. Now in part 2, we have to find the probability that the student prefers reading. For this, first we have to find out the angle of orange sector, because there is no information regarding the angle of orange sector. For this, since we have provided with 3 angles of sectors, the total number of sectors of circle is equal to 360. Now we will take away the angle of sectors that are given in the pie chart. So the angle of sector for red region is 135, and the angle of blue sector is 90 degrees. Take away the angle of green sector is 45. So after take away all the 3 angle of sectors given in the question from 360, we will get 90 degrees. So the angle of orange sector will be equals to 90 degrees. Now for part 2, let R be the event that the student prefers reading. So the probability that the student prefers reading will be equals to area of orange sector divided by area of circle and that will be equals to angle of orange sector over angle of circle. Since we have find out the angle of orange sector and that was 90 degrees and the angle of circle is equal to 360 degrees. So the probability of R will be equals to 1 over 4 after simplification. Find the probability that the student prefers basketball or chess. For this, sum the angles of blue and green sectors. So sum the angles of blue and green sector. So we will see the respective angles of blue and green sectors from the pie diagram. So the blue sector has 90 degrees and the green sector has 45 degrees. So it will gives us 135 degrees. Now let E be the event that the student prefers basketball or chess. So the probability of E will be equals to sum of areas of blue and green sector over area of circle. Sum of areas of blue, and green sector. Divided by area of circle. Now the probability of E will be equals to sum of angles of blue and green sectors divided by angle of circle. Since the sum of angles of blue and green sector was equals to 135 and the angle of circle was 360, so 135 degrees over 360 degrees will be gives us after simplification 3 over 8. So the probability of E will be equals to 3 over 8. Question 6 says, a spinner consists of a board in the shape of a regular octagon with center O and a spinning pointer. The board is divided into 4 regions and the spinning pointer is spun at random. Find the probability that the spinning pointer will stop in region S, region Q, region P, or R. So for first we have to do what? First we have to see that in the question that the shape is regular octagon, so it will have 8 sides. So first we will divide our shape of octagon into 8 parts. So first we will draw the lines. Since we have divided it into 8 parts, so we can see that the region P covers 3 parts. The region S covers only 1 part, the region R has 2 parts, and similarly the region Q has also 2 parts. So for this, for part 1, so for part 1, we have to find out the probability for region S. And since we can see that the region S covers only 1 part, and it will be divided by the number of elements in the sample space. And since we have regular octagon, so the number appears in the denominator will be 8. So the probability for region S will be equals to 1 over 8. Now for 2, we have to find out the probability for region Q. Since we can see that the region Q covers 2 parts of the octagon, so we have 2 over 8 and it will be simplified to 1 over 4. So the probability for region Q is 1 over 4. Now for part 3, probability for region P or R. Since region P covers 3 parts, plus the region R covers 2 parts, and the total number of regions we have 8. So 3 add 2 will give us 5 over 8. So the probability of region P or R will be equals to 5 over 8. Contains 3 cards bearing the numbers 1, 2, and 3. A second box contains 4 cards bearing the numbers 2, 3, 4, and 5. A card is chosen at random for each box. In the first part, display all the possible outcomes of the experiment using a sample space diagram. So in the first part, we will draw on the diagram just like draw a vertical line and a horizontal line. On the vertical line, we will put the numbers 1, 2, 3 for the first card, and the numbers we will put on horizontal axis. On vertical axis will be 2, 3, 4, and 5, and they are for second card. And now we will make a dot for each outcome. Just like for 1, 2, we have this dot. For 1, 4, we have this dot. For 1, 3, we have this dot. For 1, 5, we have this dot. And similarly, we will draw the dots for every order pair. So this was the sample space diagram for the first part. Now in the second part, with the help of the sample space diagram, calculate the probability that in the part A, the cards bear the same number. So we have to find out the probability that both cards show same number. For this, according to our sample space diagram, we have only two ordered pairs which shows both same numbers. This is order pair 3, 3. And this is the order pair 2, 2. So the numbers of element in the event is divided by the number of sample space to find out the probability of any event. So total number of outcomes in our space. Now in the part B, we have to find out the numbers on the cards are different. Since we have find out the probability for both show same number, so we can easily calculate the probability for both show different numbers. Because this is the complement of the event that both cards show same number. So we can simply find out the probability of both show different numbers by subtracting probability of both show same numbers from 1. And in first part, we have find out that was 1/6. Now the probability for both show different numbers will be equals to 6 minus 1/6, and that will be equals to 5/6. So the probability for both show different numbers equals to 5/6. Now in part C, we have to find out the probability that both numbers are prime numbers. So for this, we have to first to recall the definition of prime numbers. What are prime numbers? A number that has two factors, one and itself only, are prime numbers. So first we will identify the number of favorable outcomes from our sample space diagram. So here we have 6 outcomes that shows both prime numbers. We have, now let's take a look on the product pairs, order pairs. Here we have this order pair is 2 and 5, both are prime numbers. This order pair is 3 and 5. This order pair also shows prime number. Now for part C, we have to find out the probability that both numbers are prime numbers. So what are prime numbers? Let's recall. Prime numbers are the numbers that has only two factors, one and itself. So first we have to identify the order pairs from the sample space diagram that shows both prime numbers. So the first we have marked with circle is 2 and 5. And 2 and 5 both are prime numbers. Similarly, 3 and 5. And similarly, the other four order pairs. That shows prime numbers. So the number of favorable outcomes, or the total number of events, total number of elements in the event are 1, 2, 3, 4, 5, 6, as we can see. And the total number of outcomes in the sample space are 12. So after simplification, it will become 1 over 2. So the probability that both shows prime numbers is equals to 1 over 2.